Hello, my name is Sarah Cover, and I'm one of the program managers with Heart Math Tutoring. Let's have some fun with math. Today, we're going to learn how to play Solving Multiplication with Arrays, and it is from our Multiplication and Division notebook. The purpose of this activity is to use arrays to solve multiplication problems, as well as see how the commutative property applies to multiplication. For this activity, you will need several sheets of paper, a pencil or a pen, and if you have access to scissors, you can use them to cut your sheets of paper into fourths or just smaller pieces, which can make it easier to use them as arrays. However, if you don't, it's not necessary. So please take a moment to pause your video and gather your materials, and I'll meet you back here. Welcome back. We are now going to learn how to use arrays to solve multiplication problems. Arrays represent our rows of objects when we are solving a multiplication problem. An array shows us both rows and columns. Arrays are helpful for understanding the properties of multiplication and will later help us know multiplication combinations quickly. So let's get started. Think about the following problem. There are 7 shelves in the shoe store. Each shelf has 10 shoe boxes on it. How many shoe boxes are there in all? So my problem tells me that I have 7 shelves. It also tells me that there are 10 shoe boxes on each shelf. I'm going to start by drawing the 10 shoe boxes on the first shelf. I will use dots to represent each shoe box. Now, you see I have 10 dots in this row. So I need to make sure I have 7 shelves. And I will show my next shoe boxes for shelves 2 through 7. Now my array is complete and I'm ready to solve. So these are my rows because they are horizontal or go side to side. And my rows represent the shelves. The columns are vertical or up and down, and they represent the number of boxes. So let's solve by adding our rows of 10, and I'm actually going to skip count by 10 because that will be helpful for me. So 10, 20, 30, 40, 50, 60, 70. So there are 70 shoe boxes in all. And I don't want to forget my unit when writing my answer. Now we're going to solve a related problem on another piece of paper. And this problem is still about shelves and shoe boxes, but listen carefully because something in this problem is different. There are 10 shelves in the shoe store. Each shelf has 7 boxes on it. How many shoe boxes are there in all? What did you notice about this problem? Now, my numbers are still the same, but this time I have 10 shelves and 7 shoe boxes on each shelf. So I'm going to draw the same array, except this time for my first row, I'm going to only have 7 because I only have 7 shoe boxes per shelf. And so now I need to make sure I have 10 shelves, so I will complete for rows 2 through 10. All right, so my array is complete, and again, I'm ready to solve. So it can be tricky to skip count these rows of 7. So instead, I'm going to skip count my columns because they have 10 in each. So 10, 20, 30, 40, 50, 60, 70. So it's the same total as my first problem. So 70 shoe boxes. Let's compare the two related problems. The arrays kind of look about the same, and they use the same 2 numbers to create them. And if I turn this one sideways, it looks exactly the same as my first. And so the arrays are made up of the same amount, They're just turned different ways to match the problem. So the solution to 10 times 7 is the same as 7 times 10. So these two problems show the commutative property of multiplication, which means you can switch the order of factors but get the same product. So what does that mean? Well, 7 and 10 are my factors, which it didn't matter in which order I set my problem up, 7 times 10 or 10 times 7, I still ended up with the same product of 70. And so if we think about the problem 2 times 4, well, if we know that 2 times 4 equals 8, then 4 times 2 must also equal 8 because of the commutative property. Pretty cool, huh? So now it's time for some practice. Let's solve the related problems that you'll see on the next screen. Draw arrays to represent and solve the problems, and I'll work on solving them too. Then let's meet back here to compare our arrays and see if we ended up with the same drawings and answers. Welcome back. I finished drawing the arrays for my two problems. Did your arrays look like mine? What product did you get for both problems? If you got 28, great job. Now let's take a closer look at our two arrays. So this array goes with the problem 4 times 7 because I have 4 rows and each has 7 dots in it. And this array goes with 7 times 4 because I have 7 rows and each row has 4 dots. And then when I turn this array sideways, it looks the same as this one. Remember, when solving multiplication with arrays, you'll be drawing rows and columns. To solve using an array, you can skip count by the factor that's easier to skip count by. So for example, you could solve 4 times 7 by skip counting by 4s or by 7s. However, there's another way to solve arrays, and that's using something called the distributive property, which you may have heard of in class and which is pretty cool as well. So I find that skip counting by 4s pretty difficult, and skip counting by 7s is also pretty difficult. So instead, I'm going to look at what I do know. So for example, I know that 4 times 4 is 16. And I also know that 4 times 3 is 12. Because these are facts that I know, and so it's easier for me to see them in this array. And so then I have 16 plus 12, which I can then add in my head, and that's how I got my 28. And on this array, I used the same property, I just divided the array in a different way. So again, 7 times 4 can be a tricky fact to remember. However, I know what 7 times 2 equals, and that's 14. And here I have another 7 times 2, which is also 14. And then I have 14 plus 14, which gives me my same answer of 28. So remember, when solving with arrays, you can either skip count or use the distributive property to solve. Thank you for following along. I hope you enjoyed practicing using arrays to solve multiplication problems. If you have any questions or for additional support, please check out the resources page seen here.